Right. Welcome back, students, to the next set of reasoning questions. We've been doing reasoning questions of alkenes. Now let's see the next set, because whenever you're doing organic, not only the name reactions, not only the preparations, most important are the reasoning questions. So let's read the question and see what are the keywords we need to write in the question. Right. So, why do isomeric branch chain isomers have relatively low boiling point as compared to corresponding straight chain? Okay, so they've given us three important things. One is they said isomeric branch chain, then they said corresponding straight chain, then they said low boiling point. These three things I need to concentrate and write the answer. So what examples are given? And they're given me two things. One is isopentane and one is neopentane. What is isomeric? Iso means similar, mer means unit. Fine. Now when I take this, how many carbons are there in this count? 1, 2, 3, 4, 5. Done. Here 1, 2, 3, 4, 1, 2, 3, 4, 5. Both are having 5 carbon atoms, so isomeric. But what is the difference? They are differing in the arrangement of the methyl groups. That means in one it is a straight chain with one single branch. Here it is completely branched. Now when we observe the boiling point, here for the branched chain, the boiling point is very less, means compared to that it is 282.5. here it is 300.9. This is what they're asking us. They're asking us, why do isomeric branch chain isomers have relatively low boiling point as compared to corresponding straight chain or one branch chain at the center. Now let us write. So whenever I see, so you need to start your answer explaining about this. What are you observing? Here in branch chain, what is happening to the surface area? Here, see here, they're arranged like this, one after the other. Whenever you have to boil them, you need to break this bond, this, and gradually you need to break each and every bond. But here what happened? All the molecules are arranged in a spherical form, isn't it? So let's start writing that. In neopentane, what is this? This is a branched chain. What happened? You should tell me. Yes, simple thing. In a neopentane isomeric branch chain, first important thing, surface area decreases. When the surface area decreases, what will happen to the shape of the molecule? Yes, shape of the molecule or shape of this particular thing, shape of the molecule becomes spherical. Done. When the shape of the molecule becomes spherical, what will happen to the magnitude of London dispersion forces? That magnitude also will go down. Magnitude means measure, right? So magnitude of, I'm writing in short form, London dispersion forces or the van der Waals forces, that also will go down. So here surface area is getting less, shape of the molecule becoming spherical, magnitude of forces also, here means it is strongly packed, forces also decreasing. So once it is attaining a compact structure, it will tightly fit in the crystal lattice. Yes, when they tightly fit, let us write that also. Tightly fits in crystal lattice. These are the 4 key points which you should write. Surface area, shape, magnitude, tightly fits. This gives you a complete analysis of the whole concept. So because of these reasons, hence the boiling point is low. That's it. If you write this and underline, you will get complete mark in such questions. So this is how you're going to write this question. Let's come back into one more reasoning question. Now let's come back into 2 more reasoning questions here. Both are of the similar type. Let's read. What do they give us? Why does CH18, that is, it has a melting point of 216.2, have higher melting point than C3HA, that is 85.3. Okay, it is almost 3 times, isn't it? Fine. So why is it like that? Why do C8H18 has higher melting point? Always remember, whenever they give you a boiling point question, a melting point question, your concentration should directly go into the branching concept, right? So let's recollect again. Always higher the branching, more is the boiling point. That's the first important thing you should remember. Let us write that clue there. What is that? Higher branching means higher BP. This is for the boiling point. When I have to speak about melting point, Same thing almost. What is that? Basically, whenever a molecule is compact in nature, right? Once again, I'm coming in the other way. What is compact? It is very closely packed. When it is closely packed, what will happen? Yes, the intermolecular forces of attraction are very, very high, very compact. Means I need to melt the whole molecule, break that molecule, open it up, and then only melt, isn't it? So in this case, when I see C8H18, so what is that in this particular thing? Now we are comparing between C8H18 and we are comparing between C3 and H8. So in C8H18, we see it is 216.2. Let us write that 216.2. Now here it is 85.3. What is more in this? When I see the molecule, now in the molecule, the compact nature or the close packing of that molecule is very much more. Here it is C3H8 only. It is like this: 1, 2, 3 hydrogens, 3, 2 and 3. It is like the straight chain, no branching. But here when it comes to C8H18, there's branching in the molecule. Point number 1. And important thing is, you should remember, very close and compact packing. Compact means very close in nature, very means less space in between them. Compact packing of crystal lattice So what will happen because of this? Melting point will be high. Boiling point, listen. So melting point will be very high compared to C3H8. Simple, isn't it? So whenever you're writing that, speak in terms of compact packing or close packing, so that you can easily write the answer end of your answer. Here in this case, what is this? In isomeric alkenes, that is N-pentane, isopentane, neopentane, we have seen the earlier question in terms of boiling point. Now when I see the melting point, see here N-pentane, it is 143 Kelvin, straight chain. Isopentane a bit branched, that is 113 Kelvin. When it is neopentane, it is 256.4. The same reason, isn't it? As a molecule or the branching increases, very close packing increases. When the close packing increases, compact packing of crystal also is there. When the compact packing of crystal is there, obviously the melting point will be low. I need a lot of melting point to break those bonds and melt them. Yes, so you can write the same reason for both the questions. Now one more question based on your melting point of view. Let's see what is this. So here they've given based on melting point. Let's see the question and analyze how to write it in the exam. What do they give me? Among odd and even number of carbon containing alkanes, okay, which has lesser melting point and why? So here they've given me two things. One is they say you need to compare between odd and even number of carbon atom containing alkanes. So I need to take an alkane which is odd in nature and one more which is even in nature, right? Suppose if I take an example like, yeah, let us take N, okay, N hexane and N-heptane. Okay, let us take this example. This is a very common example, so I picked up. So what is N? Normal chain. So let's write. So I'm writing in the bond line structure, which I've already taught you how to draw bond line structure. Start from here. Hexane means 6, isn't it? So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Done. Here heptane means 7, isn't it? Now start drawing. 1, 2, 3, 4, 5, 6, 7. Let's count. 1, 2, 3, 4, 5, 6, 7. Done. Hexane means 6 carbon chain and heptane means 7 carbon chain. Now what is important? I should see which is odd and even. This is 6 carbon. It is even in nature. Here 7 carbon atom, it is odd in nature. Now they want us to compare between odd and even. Simple. Whenever they have you have a concept of melting point, remember one important thing. Boiling point means more of branching, more of boiling point. Point number 1. When it is melting point, very closely or compact packed this one, high melting point. Once again, more of branching, more of boiling point. Compact packing or close packing, more of melting point. Remember. Now they said between odd and even. Now see which is compact packing, which is compact packing. This one is even, means evenly, one after the other, second after the other, second after the other, everything will get packed. But here in this case, odd electron, after the sixth one, this will again be branching. Okay, this will again be branching, and that will not fit into the crystal lattice. Yes, so important thing, here it is even and it fits in the crystal lattice. Let us write here, it fits into crystal lattice. When it fits in the crystal lattice, what will happen? Yes, magnitude also increases, the forces of attraction also increases, and here melting point will be high, because you need to break the lattice and separate that. But when it comes to N-heptene, I said it is an odd electron, and does it fit perfectly into the crystal lattice? Yes, it will not fit. So let us write that sentence also, does not fit perfectly into crystal lattice. When it does not fit perfectly into the crystal lattice, should I use more melting point? Not required, isn't it? So melting point, what I require will be less. Done? Let's write that. So it does not fit perfectly into crystal lattice, so melting point is, or it will be lesser. So that's it. Which is having melting point? Lesser is this. Now let's write the order. Odd alkanes will have less melting point than even alkanes, because of this is the reason. Right. Now let's see one more question based on your solubility. Till now we have seen question based on boiling point and melting point. Let's read this. Are hydrocarbons soluble in water? Simple. So hydrocarbons, I know they are alkanes, alkenes and alkynes. So when does this concept of how do we write the answer for solubility? Whenever you're speaking about solubility, we think or we tend to memorize, okay, polar solvent, non-polar solvent. That is it. So what is that thing? We've always studied like dissolves like. That means polar solvent like dissolves like. It means polar solvent will, if it is a polar solvent, it will be dissolved in polar universal solvent, that is water. If it is a non-polar solvent, nature is non-polar, then it will dissolve in non-polar solvents like carbon tetrachloride, acetone, kerosene, like that. Done. So what in hydrocarbons, what is the concept? When I take this hydrocarbon, so let us write that in hydrocarbon. Let us take one example, any example. Now let us take, this is hydrocarbon chain. Okay, here you have hydrogens. Now what is this? When does this molecule dissolve? When it breaks up into ions, isn't it? When does that break up into ions? When you have a difference in electronegativity. Done. When I take the electronegativity of carbon, it is 2.55. Here for hydrogen it is 2.2. Now when there is no electronegativity difference, the drag or the pull of those particular atoms will reduce, isn't it? So the difference is very less. If the difference is more, it would try to drag the electrons towards it and create a positive negative charge, and this will become a positive charge. Whichever is dragging will become a negative charge, whichever is losing will become positive. Means deficient. So here in this case the difference is very less. That's the first most important. Electronegativity, En means electronegativity, difference is very less. When the electronegativity difference is very less, does it exist as poles, positive and negative? No, isn't it? Yes. So since, let us say, since electronegativity difference is very less, what will happen? The molecule or the hydrocarbon molecule, whatever is there, I've just taken an example, whatever is there, it exists as non-polar. If it has electronegativity difference more, it will exist as polar molecule. That means two poles, negative pole and positive pole. Due to this concept, they or hydrocarbons exist as non-polar molecule. So when hydrocarbon exists as non-polar molecule, what will happen? Just now I said polar solvents will dissolve in polar molecules will dissolve in polar solvents. Non-polar molecule will dissolve in non-polar solvents. Simple, isn't it? Done. Now we have already come to a conclusion. It is non-polar solvent or non-polar molecule. So they are insoluble in water, insoluble in water, and are soluble in non-polar solvents. Like, what are they? Just now I said, this is carbon tetrachloride, acetone, what do you say, kerosene, diesel, benzene. Okay, this is your answer. So your teacher expects you to write this word, underline this word, then you can write hence or hydrocarbons exist as non-polar, underline this word, and you can underline this word, put it in inverted commas like this, and this also in a box. That.